Hello. Today we're talking about roots and zeros. So what happens when we have something higher than a quadratic? When we have something raised to the third power? Well, start with what do we know about an equation such as this? X cubed plus 6x squared minus 9x minus 14 equals 0. Well, we know because it's a power 3, there's going to be 3 roots, or 3 answers. We also know that the factored coefficients of x are 1 because the x cubed is a 1, so each of the factors would have to be a 1x. We also know that all the terms, the last terms all multiply to make 14. So each one of these spots have to multiply to make a 14. Okay, so what else do we know? That means if I was to try and factor this and find the roots and guess and check, I'd have to check 1, 2, 7, 4, or 14, and I would have to check -1, -2, -7, and -14. Well, that's a lot to check for a number that only has 2 ways to multiply to get to 14. So one option that Descartes came up with was, he says, well, we can figure out what sign at least one of them is. What are we guaranteed? So Descartes' rule says the number of positive real zeros is the same as the number of changes in the signs of the coefficients. And same with the negatives. How many negative real zeros is when you put in a negative x inside the x spot, simplify, and how many changes. Okay, so in other words, if I have this problem, I look for how many sign changes. It's starting out positive, so positive to positive is still positive. Okay, here it goes from positive to negative. That's one change. And then it stays negative as we read it left to right. So that means there is one change which means we are guaranteed one positive real answer. If I put in a negative x, I'm going to simplify this. And a negative times a negative times a negative, if I'm cubing it, will be a negative, so a negative x cubed. A negative squared will be a positive, so positive times positive leaves a plus 6x squared. A minus x and a minus 9 make a plus 9x, and minus 14. So we have one change from negative to positive, and then another from positive back to negative again. That means there are 2 sign changes and 2 negative real answers. However, one thing I want you to know is that imaginaries always come in pairs, and so there may be 0 negatives. And I'll talk about this in just a second. So why do imaginaries come in pairs? Well, if you're taking an imaginary, you're going to have an I. If you have an I really equals the square root of -1. If you're taking a square root, that means you're taking a positive and a negative, and therefore you will always have 2 answers. You'll have the positive answer and the negative, so they always come in pairs. So if you have 2 positive roots, they could be an imaginary. You may have 0 real positive answers. if you have two negative roots, you could have two negative roots, or you could have 0 negative roots. So what we're looking for is we're actually looking for an odd number of roots. So if I came across and did Descartes' theorem and came up with 3 positives, then I could have 3 positives, but a pair of them might be imaginary. So I could have 1 positive and 2 imaginary. But I am, because there's 1 left, I am guaranteed 1 positive. So let's use this. If you're given this equation and they're asking find the roots, remember roots mean the f of x, the whole thing equals 0. Try and solve it. So let's start by using Descartes' rule. Descartes' rule says find how many positives, or real answers. Well, it's a positive x cubed, positive 6x. We got 1 change and it stays negative. So we are guaranteed 1 positive real answer. And like we found back here, so here was our 1 positive we found. We solve it again. We know there's 2 negatives or 0 negatives. We're not sure on that one. So then what we're going to do is we're going to try and next synthetic divide and use some synthetic division. So 1, 6, minus 9, minus 14. And we are going to try the factors of this. So going back to this problem, we said we had 8 to choose from, but now that we know one of them is guaranteed to be positive, these are not guaranteed to work. We only have 4 to pick from. So let's try one. Of the 1, 2, 7, and 14, let's try a smaller one because it's normally not the bigger ones. Let's start with 2. If that's too big, we can go down to 1. If it's too small, we can go up to 7. So let's try it. Bring the 1 down. 2 times 1 is 2. Plus 2. 6 plus 2 is 8. 2 times 8 is 16. Minus 9 plus 16 is 7. 2 times 7 is 14. Minus 14 plus 14 is 0. Fantastic. That means with a 0 remainder, a factor of this is x minus 2 times something equals this x cubed plus 6x squared minus 9x minus 14. Now, a byproduct of this is what we got down here is what's left after dividing an x minus 2 out of it. So we can put this back into standard form and say it's got to be an x squared plus 8x plus 7. Now, we factored this. We know that one answer is our 2 because we got a remainder of 0. We just need to see if this one factors or use the quadratic formula if it doesn't. So that is our last step. Step 3 says try and factor x squared plus 8x plus 7. We know it's an x and an x, and 7 only has factors of 1 times 7. They both have to be plus. Double check the inside and the outside make a 1x plus 7x is definitely 8x. All right, it works. So the factors of this, including our x minus 2, if this all equals 0, we can say our answers to this equation is x equals 2, x equals a minus 1, and x equals a minus 7. And we have found all 3 of our answers. Good luck. Hope this helps. Have a great day.